I'm Anil Kumar. In this video, we will learn about the Cartesian Coordinate System with the help of three examples. Now, before we get into the Cartesian system, let's review number line. So earlier, you learned about a number line which gives you position with reference to one point, and that point is referred to as the zero. Numbers on the right are written with positive increasing numbers like 1, 2, 3 and so on, and numbers on the left of 0 are given negative values, negative 1, negative 2, negative 3 and so on. So on a number line, you saw that the numbers are increasing when you go from left to right, and they are decreasing when you go towards left. And normally in a number line, what you see is distance from origin, right? So it gives you distance from origin. That is this letter O, right? Right here in the center. Now that is one dimension, right? So only one way you know how far away you are from a point. Now when we talk about Cartesian coordinate plane, we are trying to describe points on a plane like the plane of the paper, right? So here in Cartesian coordinate system, we have to say how far are you from a particular axis. So this was from a point. So let us see how it works. So here, just as we had in a number line, we'll figure out the distance from a vertical line. So here is a vertical line. We call this vertical line as y-axis. So we are looking for horizontal distance away from the vertical line, and the horizontal line is given a name x-axis. Let me write here. Okay. So any point which is described on this system is known as an ordered pair. So ordered pair is a point which gives you how far away is it from the origin, which is intersection of both the axes. So what we have here is a couple of things like horizontal x-axis, vertical y-axis, and then any point on this plane is given with the help of ordered pair, which is written in these brackets where the x value is written first. For example, if I write a value 2, 3, it really means that a point is 2 units away from the vertical line, so 1, 2, and 3 units away from the horizontal x-axis, 1, 2, 3. So that point right there represents the point 2, 3. And writing a point like this is called ordered pair. Do you understand this part? Let's take another example. If I have a point which is minus 3, 4, that really means that from the origin, the point of intersection between x and y axis, we have to go 3 units left. That negative number tells you to move left 1, 2, 3, and positive 4 means up 4, 1, 2, 3, 4. So the point which we reach is actually 3 units to left of y-axis, right? And 4 units above the x-axis. So this coordinate point here is minus 3, 4. Now if I am looking for a coordinate point in this particular quadrant, now let me tell you what are these. These are 4 different quadrants. The two axes, they intersect, and the point of intersection is called the origin. The coordinates of origin are 0, 0. And these axes, they divide the whole plane into 4 quadrants. So each quarter of this is called a quadrant. We name them as first quadrant, which is right hand and on top of x-axis, right of y and on top of x-axis. We have second quadrant, third quadrant, and this is called the fourth quadrant. You will notice that any point in first quadrant will be having both x and y values as positive, right? So here both are positive values, both x and y. In this quadrant, since you are on the left of y, the x value is going to be negative, but the y value will be positive. In quadrant 3, we are on left side of y-axis, so negative, and we are below the x-axis, so negative. So both x and y values are negative. In quadrant 4, the x value is positive since we are on the right side of y-axis, but the y value is negative since we are below the x-axis. So any point in this plane which is on the left side of y-axis will have negative x value, and any point which is below the x-axis will have negative y value. You get the idea. Now, we give a scale. So let us say each unit is 1. Then in that case, along the x, we say 1, 2, 3, 4, 5. That will be 5 units to the right, positive 5, 1, 2, 3, 4, 5, negative 5, left of y-axis. 1, 2, 3, 4, 5. This value is 5 units above x-axis, so the y-quadrant is 5, x is 0. On the other hand, if we go below x-axis, 1, 2, 3, 4, 5, the y value will be negative 5. You got the idea. So that is how we kind of assign values to every point in our coordinate system. This coordinate system is called Cartesian Coordinate System. Perfect. So we have kind of understood all parts of our system. Let's review. So in our coordinate system, we have two axes, x and y. X is the horizontal axis, y is the vertical axis. Wherever they intersect, it is called the origin, O. The coordinates of origin are 0, 0. All the points on the plane are written in the form of ordered pairs, which will be written in the brackets with x values followed by the y values. If x is positive, we are moving towards the right of y. If x is negative, we are moving left of y-axis. If y is positive, we are moving above the x-axis, and a negative value of y means move downwards, below the x-axis. The intersection of these two axes divides the coordinate plane into 4 quadrants. Quadrant 1 is on the right top. Quadrant 2 is on the left top. Quadrant 3 left below x-axis. And quadrant 4 is on the right bottom side. Each and every point in quadrant 1 will have both x and y values as positive. In quadrant 2, x will be negative, however, y value will be positive. And in quadrant 3, both x and y coordinates will be negative. In quadrant 4, positive value for x and negative for y. So that's an overall view of our Cartesian coordinate system. Now, let us take some examples. Now, let us take few examples and master what we have learned about Cartesian coordinate system. Here is the very first question for you. You need to draw a triangle by joining the points A, -3, -4, B, 3, 4, and C, -5, 2, on the Cartesian coordinate system. Find coordinates of a point So these are the 4 points which you have to find after you sketch your triangle. Inside the triangle, outside the triangle, center of segment AB and center of BC. Well, I would like you to pause the video, understand the question, take a graph paper, plot the points on the graph paper, connect them, they'll form a triangle. Once you do the first part, then you answer the rest of the questions. So let's read this question once again. First part is actually draw a triangle by joining the points A, B and C, right? So let's locate these points, join them and make a triangle. So that's our coordinate system, O being the center. So A is -3, -4. It means you have to move left and down. So 1, 2, 3, 1, 2, 3, 4. So that is the point A for us. Correct? B is 3 and 4. Means right 1, 2, 3 and up 4. 1, 2, 3, 4. So that is the point B for us. And C is -5, 2. 1, 2, 3, 4, 5 and 2 up. So that is the point C for us. So once we get these 3 points, we have to join them to form a triangle. So if I join A and B, then the line which we get will go through the origin, as you can see, correct? So just join A with B. This is called the segment AB. Now with A, let's join C also, right? So A and C forms another side of the triangle, and then let us join C to B to complete our triangle. As you know, this triangle will have 3 sides, AB, BC and CA. Perfect. So we have done the first part, that is to draw a triangle on a Cartesian plane. And in this Cartesian plane, let's write y-axis and x-axis and origin O. Perfect. Now, it's good practice to write the scale. So we'll write 1, -1, 1, -1 and 1 on all the 4 sides. Now, let us answer these 4 questions one by one. First, inside the triangle. So what we are trying to figure out now? We want to find coordinates of a point, just one point, inside the triangle. Anywhere inside the triangle. You can actually pause the video and answer these questions. So let's take a point. So if I take this point, for example, what is the coordinate of this point? This point is 1, 2, 3 on the left, so I'll write -3 and 1 above, so 1. So -3, 1 is a point for me which is inside the triangle. So I can write this as -3, 1. Correct? You could name any point. For example, you could also name this as a point which is inside the triangle, x value being 0, y value being 2. So let me give this point as 0, 2 as another point. So let me write down here, inside triangle will be -3, 1 and 0, 2 for example. Correct? Now let's look into some other points which is outside the triangle. A point outside the triangle could be, for example, here, which is 1, 2, 3, 4 on the right and 3 below. So that means 4 positive -3. This point is outside our shape, which is triangular. If you want to name another point, it could be, for example, a point right there on the x-axis, which is 1, 2, 3, 4, 5, 6, 7 units towards left. So I'll call this as -7, y 0 value, since it is on the x-axis, correct? Now, part C and D are slightly tricky. In part C, you need to find center of the segment AB. So from here to there, right in the center. And D is center of BC. So which is a point right in the center of BC. So let's do part C first. center of AB. How do we figure it out? Well, from the diagram, it is clear that it is 0, 0, but how do I get this value? Well, to get the center of AB, we are looking into center of AB. So let's call it midpoint of AB. What we need to do here is we have to find the average of x and y quadrants. So that is A, this is B, right? So what we will do to find the center? Add the x values, which are minus 3 and plus 3, divide by 2. Add the y values, which are 4 and minus 4, and then divide by 2. Minus 3 plus 3 is 0. 0 divided by anything is 0. So we get 0, 0 as expected, the center value. Correct? So that gives you a midpoint formula. Correct? So let me write down midpoint formula here. So midpoint. You can make a note of this formula. To find the midpoint, we have to add x values, let's say x1 plus x2, divide by 2. And also y values, y1 plus y2, divide by 2. Correct? That is how you get the midpoint. Now let us do this calculation for part D. Okay, so we are trying to find midpoint this time of B and C, right? So between B and C, quadrants of B 3, 4, and for C it is minus 5, 2. So to find the midpoint, I will add 3 and minus 5. So it becomes 3 minus 5 divided by 2. And the y values 4 plus 2 divided by 2. 4 plus 2 divided by 2. Now 3 minus 5 is minus 2, divided by 2 is minus 1, and 4 plus 2 is 6, divided by 2 is 3. So minus 1, 3 is the midpoint of segment CB. Minus 1 and 1, 2, 3. So right there, this point is the midpoint of CB. Do you see that? Let's call this point as P. So we have this point P, which is minus 1, 3, and that is the midpoint for the segment CB. So a lot of work we have done here. I hope things are clear. Except for this complex formula of midpoint, well, look at it once again. To find the center value, you have to add both the x coordinates, divide by 2, and both the y quadrants, and then divide by 2. Right? So you get the midpoint by using this calculation. I hope that is clear now. Perfect. But inside-outside triangle was absolutely no problem. Correct? Now let's take up next two questions. Question number 2. Here is question number 2 for you. You can pause the video, copy the question, and then answer. Name 3 points for each description. On the x-axis in quadrant 3, to the right of point A, which is minus 1, 3, and below and left of B, which is 2, minus 3. So you have to provide me with 3 points for each example. 3 points on the x-axis, 3 points in quadrant 3, 3 points to the right of point A, which is minus 1, 3, and 3 points below and left of B, which is 2, minus 3. Correct? Here is my solution. So we have our quadrant system here, y-axis and the x-axis, origin 0. We want to name 3 points on the x-axis. Origin itself is a point on x-axis, correct? So let's write down on x-axis, what do we have? 1, we have origin 0, 0. On the right side, we could have a point something here, 1, 2, 3, 4, 5. So the second point which I have selected is 5, 0. Let me take 1 on the left side, 1, 2, 3. So that is minus 3, this is 5. So another point is minus 3, 0. So if I am having any point on the x-axis, then the y value has to be 0. Perfect. Now that is part A. Let's look into part B, which is quadrant 3. Sometimes we write quadrant with capital Q and Roman letters 3. As you have seen, quadrant 1, this is quadrant 1. This is quadrant 2 for you, correct? That is quadrant 3 and quadrant 4. So we need to provide 3 points in quadrant 3. So let's take a point, let's say for example here. Now this point is 3 units left of y-axis and 3 units down. So minus 3, minus 3. So here we get minus 3, minus 3. In quadrant 3, both x and y values will be negative. Correct? Do not take any point on the axis, right? Now let's take another point somewhere here. Now this point is in quadrant 3. The value is, we already know this is 3, 4, 5, 6, 7. So it is minus 7 and 1 unit down, minus 1. Another point could be, let us say, somewhere here. So 2 units to the left of y-axis, 1, 2, 3, 4, 5, 6 down. So it will be minus 2, minus 6. So we have these 3 points in quadrant 3, and as you can see, both x and y values are negative. Now, let's work for example C. To the right of point A, which is minus 1, 3. So minus 1 and 3 is that point for us. So this is point A for us. We want something on the right side of A. That means we could have these points which are on the right of A. So those points are, so we are going towards the right side of A. A is minus 1, 3. So you can see that y value has to remain 3, correct? But the x value should be greater than minus 1. So we get here a point 0, 3, 1, 3, 2, 3, and so on. We can actually get many values. But when we say right of point, we mean horizontal, right? We mean move horizontally. Do you see that part? Very important. So you have to move horizontally to get the points on the right of any point. Correct? Now part D is kind of a test question for you. Pause the video, answer, and then check with my solution. D is below and left of B, which is 2 minus 3. So 2 and minus 3 is this point, so that is B for us. We want to go below this and to the left. So if you go left and below, that could be a point. Left and below could be this point. So likewise, you could get many points. Diagonally, I am writing these points as we are going in this direction. Do you see that? Of B, which is 2 minus 3. So the points from B will be, now this value x is 1, y value is minus 3. So we have 1, rather minus 4, right? 1 below minus 3, so minus 4. So when I say left, then the x value is lesser than the x value of B, and to the left and down means y is also less, right? So you could just decrease both by 1 each. So you get 0, minus 5, and you also get minus 1, minus 6. So likewise, you could get many other points. I hope this concept is clear, right? So when I say right of a point, we have to move horizontally, where when I say below and left, we are moving kind of diagonally. Do you see that? That is how you could get more points. Now, E for you is right and above, let's say point C, which is, let's say, origin. So that is for you to practice. Give me 3 points which are right and above of 0, 0. Perfect. So I hope that sounds better, right? You're feeling more comfortable now? So let's move on and take up the last question. And that will help you to understand coordinates of points on a grid perfectly. Now here is a thinking question for you. Let me say tips. Question number 3. The point AB has integer coordinates. Describe the possible position of AB for which the quotient A over B will be positive, negative, 0, or undefined. So we have 4 different parts. So A and B are coordinates, x coordinate and y coordinate, right? So we are given here A and B. So in this, A is the x coordinate and B is y coordinate. What do we need to find? We need to find the value of a over b, right? A over b, that is the quotient. So when we say quotient of AB, it means this ratio A over B, right? Now, when will this ratio be positive? When will this ratio be positive? Think about it. So let me just sketch a coordinate system here. So we have x-axis horizontally, y vertically with 0 at the origin. Now if I want A over B as positive, that means I could have my points either in quadrant 1 or in quadrant 3. Do you see that? So in this case, both A and B are positive. In this case, both are negative. Positive divided by positive gives you positive. Negative divided by negative gives you negative. Do you see that? And also remember, in such cases, B is never equal to 0 since you cannot divide by 0. If you divide by 0, you get undefined points. Do you get some idea? So with that help, I would like you to pause the video now and then answer. Give me 3 points so that the ratio A over B is positive. Let's begin with this. Well, so in quadrant 1, we'll have both positive. So a point here could be, for example, I could give a point 1, 2, right? So that will give me positive when I divide 1 by 2, right? I could also write 4, 1. That is also positive. I could also write down minus 1, minus 3. A point in quadrant 3. Since both are negative, when you divide them, you get positive result. You get the idea. Now let's do the next one, where we are looking for 3 points. If A divided by B, then we get negative result. Do you see that? Quotient is negative. In this case, we're looking for points in quadrant 2 or in quadrant 4. Perfect. So a point could be quadrant 2 points, for example, here will be minus 7, 1, for example, right? Now if I divide minus 7 by 1, I get negative 7. So negative, you understand? Perfect. If I take a point here, let's say if I take a point which is 4 minus 2, if I divide 4 by minus 2, I get minus 2, a negative number. Likewise, we can select many points. There are infinite number of points on our coordinate system, right? Now let's choose another point at random, but it has to be in quadrant 2 or 3 to give our quotient as negative. So let it be 1 and minus 1. So either one of them could be negative. So for part A, both should be positive or both negative. In part B, either one of them should be negative. Opposite signs, correct? Now, part C. When can I get 0 when I divide A by B? That means A should be equal to 0, right? So that means A should be 0. So if I write 0 here and any other number, 0 divided by 1 is 0. So that means we are looking for points where A value is 0. Correct? Which are those points? A value will be 0 if you are talking about y-axis, right? So 0, 1, 0, 2, or even 0, minus 1, or wherever. So these are the points on the y-axis. Do you see that? So we could write 0, 1, we could write 0, 2, we could write 0, minus 3, for example. Correct? Now when I say that the point should have undefined ratio, that means B is 0, right? Only then it will be undefined. B 0 means y value being 0. So now we are looking for points on the x-axis. So the points will be of the form x value will be something, let's say 2, but y value will be 0. So if I divide 2 by 0, I get undefined number, right? So it could be minus also, right? We could write minus 1, 0, or we could write 3, 0. But the y value should be 0 to get the quotient as undefined. You get an idea, correct? So with that, we kind of close this, and I hope you understand all the concepts. So we are working with a coordinate plane in which x-axis horizontal axis, y-axis is vertical axis. Any point is written as x and y. X coordinates how away you are from y-axis horizontally, and y gives you how away you are from x-axis, up or down, correct? If you're going up, y is positive, going down means negative. Intersection of these two axes gives you origin and 4 quadrants. Perfect. So I hope that helps. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. So in the next video, we will talk about translations and then rotations of figures in the coordinate plane. I hope that works for you. Thanks for watching and all the best.